Alright, hello everyone. In this video we are going to do definite integrals. In the last one, it was indefinite. This time we're going to do definite integrals. And you'll see the difference in the very last step, how you'll know when it's definite and indefinite. So, again, we said the way you write an integral is you have this large S, and then you have a function, f of x, to the dx. But this is the difference between an indefinite and definite. A definite integral always has 2 points, a to b, where you're going to integrate from, right? The last one didn't have those points. It was just a general function formula. This time you're going to get a value instead of a function back. So let's do an example. So let's say we have the integral, right? Let's keep it simple. 0 to 1. Keep it very simple. Of 4x cubed plus 6x squared minus 2x plus 1 dx. I like to put this in parentheses just to keep it neat. So we are going to take the integral of each individual thing, right? Kind of like I said in the last video, how you take the derivative with the power rule of each individual thing. You do the same thing with the integral, always. So what you'll do, again, you take out the constant. So with the first one, 0 to 1, x cubed dx plus 6 integral from 0 to 1, x squared dx minus 2 integral from 0 to 1, x dx, and finally plus, we'll just write 1 for argument's sake, why not, dx, right? Alright, so you're going to take each individual integral, right? And again, with practice, it becomes a lot easier. You'll just be able to do them all in one step. But for now, just do it separately. So for the first one, you'll have 4 times x to the 4th over 4. So now this one's done. Plus 6 times x cubed to the 3rd power, x to the 3rd power over 3, minus 2x squared over 2. And then always the integral of dx is always x, right? Plus x. And then what you should do now is try to see if you could simplify it, which in this case, you could simplify almost every single term except the x. So over here, these 4's will cancel out, and you're left with x to the 4th plus 6 divided by 3 is 2, x cubed, minus 2 divided by 2 is 1, so you don't have to write the 1, minus x squared, then plus x. Alright, now if this was an indefinite integral, you'd have to write plus c, right? Because you always assume there's a constant. But this is a definite integral, so you have these values that you go from, right? And so what you'll do, so just erase that. So what you do, this is the final step. You're gonna put a 1 here and a 0 here. And you're gonna set them equal, right? What you do, I'm gonna write it back up here. So it's always f of, my gosh, always f of, what is going on? F of b minus f of a. All right? That's how you find the value of a definite integral. You do f of b, the integral of it, minus f of a, right? So this is actually capital F, not lowercase f. There we go. So let's plug in 1. So we'll do 1 to the 4th power plus 2 1 to the 3rd power minus 1 to the 2nd power plus 1. I like to put these in brackets just so that I don't lose track of them, right? Then minus. Now, this is important about zeros. In most cases, when you just have functions of x, polynomials, you could just ignore it, right? Because 0 to the 4th plus 2, 0 to the 3rd minus 0 to the squared plus 0 is just 0. So in cases where you have 0 at the bottom, you could just take the first number, and that will be your last answer, right? So 1 to the 4th power is 1. 1 cubed times 2 is 2. 1 squared is 1, but negative, so minus 1, plus 1. So 1 plus 2 is 3, minus 1 is 2, plus 1 is 3. And that, oops, I forgot I have a highlighter. And that is your final answer. So you see, with a definite integral, you get a value instead of a function. If this were an indefinite integral, this right here would be your final answer, but with a plus c. You'd have to write plus c, right? But since this is a definite integral, you're getting a value.